Hello again, and today we're going to have a look at ratio, what it actually means, and the notation that is used for ratio. So in the example that I've written down, we are comparing two amounts in the same unit of measurement, and that's why I've specified that we're measuring in cups. So it has to be in the same unit of measurement. And here, for anybody who bakes, we all enjoy eating baked things, I think, but some of us also enjoy baking. If you enjoy baking, you'll know that unless you get the correct amount of the proportion of the ingredients correct, your cake is either going to flop or your batter is not going to bind properly. If you're mixing cement or concrete and you mix the wrong ratios of water and sand and cement, you're going to get too runny a consistency, or it's not going to set, or it's going to crumble. So ratio is actually something that's really important in everyday life, and it crops up in all, I've just given you two examples, it crops up in all facets of life. So just to specify, it has to be comparing two amounts in the same unit of measurement, but that's not how you would actually write it. You would write it as 1:3. So we don't include the unit of measurement in the ratio, because in another situation when we're wanting to make a bigger cake or make a whole lot of cakes out of this particular recipe, we might decide instead of measuring in cups, we want to measure in kilograms. Then for every 1 kilogram of sugar, we would put in 3 kilograms of flour. So the ratio written like that allows us to use whatever unit of measurement we want when we're actually using the ratio. So let's see now what actually happens with ratios. First of all, a ratio might not be given in its simplest form. And in this one, I'm not telling you what I'm comparing, I'm just giving you the ratio form of it. So here we've got quite big numbers, 35:50, which means for every 35 measurements of whatever you're doing, you're going to need 50 measurements of the other substance that you're using. But that's very messy, it's such big numbers. So a ratio can actually also be written as a fraction. So that could have been written as 35/50. And if we think back to our fraction lessons, when we wanted to simplify a fraction, we had to find the highest common factor that could divide into the numerator and into the denominator. So we're doing exactly the same thing here, except the numbers are next to each other. So obviously the thing that will go into both of them is 5, and 5 goes into 35 7 times, and 5 goes into 50 10 times. And because there's nothing to divide into those two, my ratio is now in its simplest form. So let's have a look at another one. 24:40. So in this one, I'm going to make a little bit of an error just to show you that it's not a train smash. You can actually keep going if this happens to you. So if you looked at these two numbers and your tables aren't very good, you might have spotted the 4, the fact that 4 goes into both of them, and said 4 into 24 goes 6 times, and 4 into 40 goes 10 times. Well, if you look at those two, they are both even numbers, and we know that any even numbers are divisible by 2, so we didn't choose the highest common factor. But that doesn't matter as long as we keep going. So we've realized they're still divisible by 2. 2 into 6 goes 3 times, and 2 into 10 goes 5 times. And as we can see, there's nothing that will divide into those two. So if you don't think of the HCF straight away, you might just have to do an extra step. But as long as you keep going until it's simplified, that's not a problem at all. So let's have a look now at if we're given an example that has got different units of measurement. I specified there we had to measure in cups and in cups. If we were using cups for the one, we had to for the other. So these are both units of measurement for length, but they're not the same unit. So what we've got to do in our first step is basically get both of them to be millimeters or both of them to be centimeters. Now you'll see when you start working with these that it's always best to choose the smaller unit, because otherwise you'll often end up with decimal numbers, and we don't like decimal numbers in a ratio. So I'm going to make sure both of them are in millimeters. How many millimeters in a centimeter? They're 10, so I have to multiply that by 10, which gives me 120 millimeters. This one I don't have to convert because it's already in millimeters. And this is the last time I'm going to write millimeters, because remember, in our final ratio, we need to have just the numbers. So these are both tens numbers, and that means I can divide both of them by 10, but I want to just take a shortcut to make it easier. So whenever I can divide by 10, I can just actually cancel that 0 off. That means I've divided that by 10 and I've divided that by 10, which means now that I've got 12 and 8. So what number goes into 12 and into 8? Obviously 4, and 4 goes into 12 3 times, 4 goes into 8 twice. A very nice simple ratio, and I'm sure you'll agree it looks a lot simpler than that. Much easier to understand. Let's have another look at some more that have got different units of measurements. 170 meters to 1 kilometer. So again, I've chosen two that are both units of length or units of distance, but they're not the same unit. If you convert this into kilometers, you're going to have a decimal, and that's going to be a big mess, I promise you. So you choose the lower one. I'm going to have both of them in meters, so this one's going to stay as 370 meters. And how many meters are there in a kilometer? There are 1,000. So instead of writing 1 kilometer, I'm going to write 1,000 meters. So again, they're multiples of 10, which means I can divide that one by 10 and I can divide that one by 10. Don't get carried away here and start cancelling off all these zeros. Maths is fair, so whatever I do to that side of the ratio sign, I do the same to the other side. I've divided by 10, I've divided by 10. So now I'm left with 37 and 100. So if you know your tables well, you'll know that 37 is a prime number, and 37 definitely doesn't go into 100. So even though it looks a bit messy, that is my simplest form of my ratio. Right, one last one. Let's have a look at 4,5 liters to 500 milliliters. Right, again, liters are a bigger quantity than milliliters, so I'm going to convert both of them into milliliters. How many milliliters in a liter? 1,000. So when I multiply this number by 1,000, I'm going to end up with 4,500 is to 500. All right. Both of them are in the hundreds, so I can divide that by 100 and I can divide that by 100. I'm left with 45 here and 5 there. Nice and convenient. I can divide both of them by 5, so 5 goes into 45 9 times and 5 goes into 5 once. And that is the simplest way to get your ratios into simplest form. And in the next video, we'll go on to sharing in a specific ratio.